All right, so what we're going to talk about now is the second rule inside of 3.3, and that's the multiplication rule. And the multiplication rule is very important. It's kind of crucial, and we're going to be using it quite a lot inside of this course. And it's basically what it is it's saying, well, what if, right, we wanted to find, okay, the probability of A and B, okay? And we didn't actually have, we have probabilities that we can work with, but we don't actually maybe have the sample set, the set, whatever it is that we might be looking at. Well, the probability of A and B is going to end up equaling the probability of A times the probability of B given A. All right? That's why it's called the multiplication rule. Is we're going to take the probability, we want to know the two events occurring, and that's going to equal the probability of the first event times the probability of the second event given the first event occurred. Okay? And so the reason why something like this it ends up being very, very handy, and the reason why it is so handy is because it allows us to kind of think about probabilities away from the sample spaces and to work with them on a much larger basis. Now, if I go through and I rewrite this, this is also going to mean that the probability of A and B divided by the probability of A is going to equal the probability of B given A. So it's actually also going to give us our conditional probability, and I'm going to talk about that one first because it turns out that that one's actually the one that's most intuitive to understand. So if you remember when we talk about conditional probabilities, right, the probability of B given A, this becomes our new sample space. Okay? And B has to be drawn from the new sample space. So consequently, the number of B's that we're looking for is going to end up being however many there are that are in both A and B. Because we're picking only from A and they have all the qualities of B, so consequently it's going to be A and B. Okay? And then our A, right, that's our new sample space, so that's the new size of the total. Right? And that's kind of how we're thinking about it. So this kind of works a lot like conditional probability. In fact, it works exactly like conditional probability. Okay, so let's take a look at, suppose we are to pick a queen from a deck of cards. Okay, so we're going to first pick a queen from the deck of cards. And we want to know what is the probability. We have a queen with the first card and a queen with the second card. All right, so let me kind of talk a little bit about how these kind of card stuff works. Okay, so there are 4 queens in a deck, and there are 52 total cards. So the probability of picking a queen is going to equal 4 out of 52. Okay. Now I should say we're going to do this without replacement because that's going to end up being important. Without replacement. So I have 4 out of 52 for the probability of picking a queen. Now the probability of picking a queen second, given that first picked the queen first. So what we did there was we picked a queen from the deck, and then we took the queen out. Okay, so now we no longer have that value inside of the deck. And so what we're going to do now is we're going to pick another queen. So here's our new sample space, is the queen first, right? And then we're going to pick a queen second. So now we only have 3 queens in the deck, and then we're going to be out of 51 cards. Okay? So our probability that we're looking for, the probability of queen first and queen second, is going to equal the probability of a queen times the probability of a queen second given the queen first, which ends up equaling 4 out of 52 times 3 out of 51, okay, which we can actually do. That's 1/13, okay, times 1/17. And so that ends up equaling 0.005, approximately 0.005. So what I want to show you, and what you want to notice here, is that first, right, I wanted to know the and. Okay, I wanted to know the and version. And so in order to figure that out, what I had to do was I first multiplied the probability of the queen first, right? So we pick out a queen at random from the deck that's full. So that's now 4 out of 52. And then I'm going to multiply the probability, the conditional probability. So the conditional probability of queen second given the queen first. And there we go. And that actually ends up giving me my total probability. Let's take a look at one more example, and we'll kind of use the other alternate definition. Okay. Suppose the probability of selecting a student in Math 219 and English 101 is 0.17. Okay? And suppose that the probability of picking a student at random in English 101 is 0.14. Excuse me, 0.41. What is the probability that we pick a student who is in Math 219 given that they're in English 101? So what our multiplication rule is going to do is it's going to say, okay, well, what do we know? We know that they're in English 101. And so according to the multiplication rule, the probability that a student is in Math 219, okay, given that that we already know that they're in English 101, is going to equal the probability of English 101 and Math 219 divided by the probability that they're in English 101, right? That's just the formula that we're going to use. It actually is the relationship that we've got going on in this probability. So now, okay, I take that and I say, okay, well, given that that's the case, I know that this is going to equal 0.17 divided by 0.41. And that's 0.0697, or 0.06, or 0.07. So it's approximately 0.07. Okay? So it actually, the multiplication rule also allows us to find, okay, the probability of a conditional probability as well, okay, by taking the intersection of the two and dividing it by our new sample space. All right? So let's kind of review. What do the multiplication rules say? Well, the first one is to say that the probability of A and B is going to equal the probability of A times the probability of B given A. Okay? Or it'll say that the probability of A and B divided by the probability of A is equal to the probability of B given A. They're actually the same statement. We've just done a little algebra with them. Allow me to actually make sure that you can catch on to something that's a hint that'll help you to make fewer mistakes here. If we look, our probability, right, that we have this occurrence, Math 219 given English 101, we know that we need the probability of both of them occurring at the same time. English 101 and Math 219, and then make sure that you're dividing through by this value on the bottom, the English 101. Okay? So as you're working with your equations, right, make sure that you define what A and B are and that they are actually in the correct places when you're working with the equations. This completes the section.